Okay, so we're going to be looking at one-sided limits again. Okay, and we're going to find out if something exists or doesn't exist. So we're going to start with our very first question here. A. The limit of x as it approaches 0 from where?
The right.
The right. Okay. And in order for something to exist, remember, it has to be continuous, okay? Well, actually, it doesn't have to be continuous. It just has to be existent at that point. We're going to solve, first of all, for when, so here's our A, limit of x approaches 0 from the right. We're going to actually solve for when x is 0. And because we're approaching from the right, we're going to figure out a value that's infinitely close to 0, but from the right would be a little bit larger. So think of it like on a number line. Okay? So if we're on a number line, and this represents 0, maybe this represents 0.1, this represents 0.2. Well, we want a number that is extremely close to it, almost at 0. So we're coming at it from the right, but we're not quite at 0. So maybe something like x is equal to 0.001. That would be really close to 0 and approaching it from the right side. Okay, so we're going to approach it from the right. So the limit of x as it approaches from the right, 4, and we're going to substitute in our 0.001. Okay, we're going to discover that the limit as x approaches 0 from the right. Well, I got to find the fourth root of 0.001. So 0.001 to the fourth root. I think that'll do it. Let me just double check. Power of 4. Yeah, that's right. I just wasn't sure if I was on the right button. Okay, right? So we got 0.117. So
it's 1.7.
Oh, 0.17?
1.77.
177. Okay, and the smaller our value goes, this value is going to continuously get closer and closer to 0. And on a graph, do you remember our, well, this is the root of something. On a graph, what this is, approaching from the right will exist because we can find the fourth root of any positive value. So because it's positive, yeah, it's a little farther from 0 from our number, but it's still approaching 0. Okay, and we know that if we actually find the limit or we find the fourth root of actually 0, it's going to be equal to 0. So you can think of it like, yes, we are approaching 0. So the limit does exist. We're at 0, and it's approaching 0 from the right, you could say. Okay, our B may be a little different. The root of x minus 3. So limit of x as it approaches 3 from the right. And what is it? Root of x minus 3?
Yeah.
X minus 3. Okay. So again, on a number line, what would be just to the right of 3? Something like
4.
Okay, you could say 4, but you could also say 3.001, something like that. That would be much closer and just to the right of 3. So let's plug those values in and see what we get as our limits. In the first one, the limit of x as it approaches 3 when x is 0.001, so approaching it from the right. Well, this value ends up being the root of 0.001. We know what that is, right? We know that is going to be, we've solved it in the last question. Sorry, write the limit out again. This approaches.
Do you have to keep writing?
Yeah, technically we do, right? It's 0.17, right? We know that it's 0.177. So as the limit as x approaches, as x approaches, I did it again, approaches 3 from the right is 0.117. And we know that when x is actually at 3, 3 minus 3 gives us the square root of 0, which is 0. So we're in the same boat again. Yeah, this exists, okay? How about the last one? did it go? Oh, there it is. The limit x approaches 1 from the left. Okay. Very last one. The limit of, is it x minus 1 or 1 minus x? 1 minus x. No, it's confusing. 1 minus x as x approaches 1 from the left. Okay, well, from the left of 1, what value would we have?
Negative. Zero.
Well, if it's to the left of 1, we're still going to have 0. You could say 999. That would be just on the number line. That would be just to the left of the number 1, right? That would be like maybe right there. Be very close. So we can make these numbers even closer and closer as much as we want. Okay. So as we approach it from the left, essentially what's going to happen? Let's think of it like this. This value, we don't have to equate it. This value x is going to be less than 1. So 1 subtract this, we'll still get what? A positive or negative number?
Negative.
Let's actually work it out. 1 subtract 0.999. It's actually going to give us
I have no idea. But
0.001. Same type of thing we did before. I should have wrote the limits in here technically. X approaches. So what's ending up happening is these limits are existing. But in this case, let's say they had said the limit of x as it approaches 1 from the right. Okay, let's say you approached it from the right. Same equation. Well, in that case, we'd be working with what? 1.001, right? Well, if I plug that in to our limit of x as it approaches 1 from the right, 1 subtract 1.001, what kind of value are we going to get?
0, 0.
Right. Is when I subtract those, I'll show you what happens. 1 subtract 1.001, negative 0.001. Can I find? No. So at this point, it does not exist. Okay. Or it doesn't exist from the right. Okay. From the left, it exists, but from the right, it doesn't exist in this question. Okay. So that's the idea. Does it exist from the right? Does it exist from the left? And this is how we solve it algebraically. We take numbers that are very, very close to them, and we test them out.